From a single crystal X ray diffraction experiment, one can obtain the three-dimensional structure of a particular chemical compound. In other words, see the bond connectivity and spatial arrangement of atoms that make a particular crystalline substance. This type of experiment requires a perfect single crystal of a substance, which is then mounted onto an X ray diffractometer to record X ray images from which the crystal structure can be determined. First, you will need to grow a crystal of your sample to an adequate size for analysis. Once suitable crystals have been obtained, use a spatula to place a few on a glass slide. Place a drop of oil onto the crystals, as it will make it easier to manipulate them and select the best candidate. Selecting a crystal can take some time, as not all crystals diffract as well as others. The best crystals are around 0.4 mm in diameter, with regular faces. The first crystal is exceptionally small, and this will be weakly diffracting and not a good choice. The second crystal is definitely not single, and is made up of more than one crystal. The third crystal is cracked and unsuitable. The final crystal would be the favourable one to use. The next step is mounting the crystal onto a nylon loop. This requires a scooping action and is made easier with the oil, which also helps with steadying the crystal on the loop. The Crystal Lab Mini instrument is operated through the software program Crystallis Pro. Open the software on the PC. Several components make up the single crystal diffractometer. There is an X-ray source, a goniometer head and an X-ray detector. The goniometer head is used for rotating the sample. A beam stop is located directly opposite the X-ray source to block the transmitted X-rays and prevent burnout of the detector. It is a good idea to conduct an experiment at low temperatures, as this keeps the crystal stable and lowers the thermal motion of the atoms within the crystal lattice. Therefore, we have this low temperature device. To open the door of the instrument, press Door Lock, which turns the X-rays off. A beeping sound occurs when the door is unlocked and open as a safety precaution. Place your sample on the magnetic base of the goniometer head. Centering the crystal in the path of the X-ray beam is made possible through Crystallis Pro. Press the mount button in the software and a video image of the crystal will appear. Use the control buttons on the software to rotate the crystal by 90 degrees, and use the key to adjust the crystal until it is centered no matter the orientation. Close the door and press the Door Lock button. Using the screening option in the software allows for preliminary diffraction data to be collected. From the few frames collected, you can decide whether or not the sample is suitable for a full data collection or if a new crystal needs to be selected. This is a good diffraction pattern. It has spots that are regularly spaced and evenly distributed. The spots should be discrete and circular. A poor pattern could have streaks, diffuse clouds, multiple or split spots. If there are only one or two spots, then the crystal is too weakly diffracting. Once a suitable crystal has been found, a pre-experiment is run. A total of 15 diffraction images are collected in 3 different orientations to determine the best full data collection strategy for the sample. This allows for a more accurate determination of the symmetry and the unit cell parameters of the sample. If the diffraction pattern seems okay, but it is not diffracting to the higher angles, it is worth increasing the exposure time and performing another pre-experiment. After the pre-experiment, a data collection strategy box will appear. Before clicking the Start Experiment button, there are a few things to check beforehand. If you know what unit cell you're looking for, check to see if it's correct. Check that the orders of magnitude of the unit cell is sensible for the molecules involved. Check the percentage of reflections that match the given unit cell. Look at the total experiment time and check that it is suitable. With experience, you will know the effect of adjusting the exposure time. A longer exposure time will yield better results, but too long can damage the detector. Press Calculate New Strategy if you have changed anything on the right-hand side of the screen. The total time will change automatically if you change the exposure times. If you are happy with the strategy, Start by pressing Start Named Experiment. Enter your sample name and chemical formula. Choose a directory to save your results. Edit your sample description and press Start. The instrument will now automatically begin to collect your data, after which the data will be ready to analyse. After the data collection is complete, the structure is solved in the OLEX2 software.